Hallo und herzlich willkommen zur Ringvorlesung Informationswissenschaft und Digital Humanities hier an der Heinrich-Heine-Universität in Düsseldorf. Und ich möchte Sie heute alle ganz herzlich zu unserem Auftakt begrüßen, dem wir gemeinsam mit dem Vortrag von Indira Sen Social Media-Based Measurements of Psychosocial Phenomena, Potentials and Pitfalls, also zu Deutsch auf sozialen Medien basierende Messungen von psychosozialen Phänomenen, Potenziale, aber auch Fallstricke beginnen und starten. Und genau, ich habe es gerade auch schon gesagt und angekündigt, wir. Und wer genau sind wir? Wir sind einmal ich selbst, Isabelle Dorsch. Ich arbeite an der Abteilung für Informationswissenschaft an der Heinrich-Heine-Universität Düsseldorf und organisiere das aber zusammen mit meinen beiden lieben Kollegen, Frau Dr. Aylin Imeri und Stefan Reiners-Selbach, die ich jetzt aber auch gerne selbst zu Wort kommen lassen möchte.
Ja, herzlichen Dank, liebe Isabelle, und auch von mir natürlich an Sie alle da draußen. Herzlich willkommen zu unserer Ringvorlesung zum Auftakt. Mein Name wurde ja bereits gesagt. Ich bin Aylin Imeri, arbeite ebenfalls an der Abteilung für Informationswissenschaft an der Heinrich-Heine-Universität in Düsseldorf, bin Postdoc und forsche an verschiedenen Themen, unter anderem an Social Media und das Nutzerverhalten, aber auch an dem Gesundheitsverhalten von Nutzern, die Wearables, Activity Tracking Technologies zum Beispiel nutzen und immer eben aber der Nutzer und die Technik im Vordergrund und wie eben mit Informationen umgegangen wird. Und das reicht, glaube ich, auch erstmal schon zu mir und damit übergebe ich nämlich auch an meinen netten Kollegen.
Ja, vielen lieben Dank. Euch beide noch von mir herzlich willkommen. Ich bringe so die Digital Humanities Perspektive mit in die Runde, denn das ist auch meine Aufgabe. Ich koordiniere die Digital Humanities an der Philosophischen Fakultät der Heinrich-Heine-Universität. Und ich freue mich riesig auf dieses interdisziplinäre Gebiet und auf all die Diskussionen, die wir in dieser Vorlesung haben werden.
Ja, vielen Dank, ihr beide. Und genau, das erstmal vielleicht zu uns als Team. An dieser Stelle möchten wir aber auch noch mal ganz herzlich allen danken, die uns geholfen haben, die Ringvorlesung auch dieses Sommersemester wieder auf die Beine zu bringen. Und deswegen gilt da auch noch mal ganz stark unser herzlicher Dank einmal an das Multimedia-Zentrum der Heinrich-Heine-Universität Düsseldorf und natürlich auch an allen KollegInnen der Heinrich-Heine-Universität Düsseldorf, die eben auch im Hintergrund mitgeholfen haben, die Ringvorlesung auf die Beine zu stellen, die Technik bereitzustellen und auch fleißig Werbung für die Veranstaltung gemacht haben. Und natürlich aber auch Sie als zuschauende Personen, die eben ja auch unter anderem schon fleißig Werbung gemacht haben und jetzt ja auch mit dabei sind. Und wie bereits gerade auch gesagt, ist das heute unsere Auftaktsitzung mit Indira Sen von dem Leibniz-Institut für Sozialwissenschaften GESIS. Und sie hat eben heute ihren Vortrag über die Social Media-Based Measurements. Daneben haben wir aber natürlich auch noch andere Vortragende und Sie sehen das hier auch gerade schon auf den Folien, wer noch mit dabei ist, welche Themen noch dabei sind und auch an welchen Terminen das Ganze stattfinden wird. Und Sie sehen, wir haben insgesamt 6 Sitzungen, die jetzt dann auch online stattfinden werden. Wir haben auch zusätzlich eine Webseite, wo Sie auch noch mal mehrere Informationen über die Speaker finden. Und darüber hinaus ist das aber auch noch nicht alles zur Ringvorlesung. Es ist auch so, dass wir einmal, oder wie Sie auch vielleicht schon mitbekommen haben, an den Titel heute, die Vorträge sowohl auf Englisch als auch auf Deutsch haben werden. Also da variieren wir ein bisschen. Und zusätzlich haben wir auch noch ein Abschlussevent am 15. Juli 2022. Und das Abschlussevent werden wir dann auch mit Ihnen in Person stattfinden lassen. Und zwar mit einer Panel-Diskussion in der Oase im Forum des Austausches hier bei uns an der Universität in Düsseldorf. Also Sie sehen, wir sind sehr nicht nur thematisch interdisziplinär, sondern auch von der Technik sehr variabel in dem Sinne, dass wir sehr hybridmäßig die Online-Veranstaltung eben aber auch mit einer Präsenzveranstaltung kombinieren. Und genau, neben der Panel-Diskussion, die wir in der Abschlussveranstaltung haben werden, ist es so, dass das natürlich auch nochmal dann den Aspekt oder den Impuls geben wird, die Aspekte, die wir in den verschiedenen Sitzungen gemeinsam jetzt dann thematisiert haben, wieder aufgreifen werden, da dann auch nochmal die Möglichkeit haben, in den Dialog miteinander zu treten und Sie auch die Möglichkeit haben, miteinander ins Gespräch zu kommen und sich zu vernetzen. Genau, und was bleibt mir sonst noch zu sagen? Also natürlich möchten wir Ihnen auch schon jetzt sehr gerne mit Ihnen diskutieren und eben auch Ihnen die Möglichkeit geben, Fragen zu stellen, Ihre Gedanken und Meinungen zu äußern, auch zu dem Vortrag. Und deshalb sehen Sie auch eine Livebox für das Meeting für Fragen und Kommentare hier auf der YouTube-Seite. Und es wird so sein, dass nach der Präsentation von Indira Sen eben Stefan mit den Fragen von Ihnen auf mich zukommen wird und Sie die Möglichkeit haben, dann in dieser Livebox auch während des Vortrages schon eben die Fragen zu stellen. Zu einem späteren Zeitpunkt gibt es dann aber auch immer noch die Möglichkeit, die Kommentarfunktion zu nutzen hier auf YouTube. Der Chat wird dann nämlich nicht mehr verfügbar sein. Und darüber hinaus, Sie sehen es auch schon in der Fußzeile vielleicht auf unseren Folien. Wir haben auch einen Hashtag, der Hashtag Ringvorlesung ISDH. Sie können den natürlich auch sehr gerne nutzen, wenn Sie über die Veranstaltung in irgendeiner Form ins Gespräch kommen möchten, außerhalb von YouTube. Genau, und ich denke, für alle, die vielleicht auch noch nicht oder die auch jetzt nochmal neugierig geworden sind bei dem Programm, das ich Ihnen gerade schon in der Übersicht gezeigt habe, wie gerade gesagt, es gibt dazu eben auch eine Webseite, die werden meine Kollegen jetzt gleich auch wahrscheinlich nochmal in den Chat reinposten, aber die wird auch so für Sie verfügbar sein, wenn Sie eben über die verschiedenen Kanäle ja auch vielleicht schon da drauf geguckt haben, über die Werbung. Und das sind soweit auch erstmal so die ganz allgemeinen, einleitenden Aspekte zu unserer Ringvorlesung. Ich möchte es aber auch gar nicht zu lange jetzt machen und deswegen starten wir jetzt einmal noch mit den inhaltlichen Aspekten zu unserer Ringvorlesung, dass wir nochmal Ihnen ganz kurz erklären, was der Gedanke dazwischen ist oder dahinter ist, Informationswissenschaft und Digital Humanities als Ringvorlesung zu thematisieren, um dann direkt weiter auch mit unserem ersten Vortrag zu starten. Und damit übergebe ich auch wieder ab an meine Kollegin Aylin.
Genau. Also eigentlich hat es ja meine Kollegin Isabelle gerade schon sehr schön gesagt. Es gibt quasi hinter dieser Ringvorlesung zwei Disziplinen, die Informationswissenschaft, Digital Humanities. Und da haben wir uns dann gedacht, warum nicht versuchen, das Ganze doch mal näher zu bringen und aber auch zu schauen, was sind das eigentlich für zwei Disziplinen? Eine ganz oft gehörte Frage, sind es dieselben Disziplinen? Was verbindet diese Disziplin und was unterscheidet aber auch vielleicht diese Disziplin? Und das können Sie auf dieser Folie dann eigentlich auch schon sehr schön sehen. Wir wollen jetzt erstmal so starten, dass wir erstmal dabei weiterhin bleiben und sagen, okay, wir haben einmal die Informationswissenschaft mit ganz vielen Inhalten, Methoden. Wir haben Digital Humanities ebenfalls mit ganz spannenden Inhalten und auch Methoden. Und dann gibt es die Schnittmenge. Und wir hoffen natürlich, dass wir auch insbesondere mit den Vorträgen uns diese Schnittmenge dann auch genauer ansehen können und trotzdem aber beide Disziplinen auch in ihren Stärken und Herausforderungen natürlich näher thematisieren können. Nächste Folie bitte. Genau. Und damit bekommt das Stichwort auch schon eigentlich wieder der Stefan.
Genau, also ihr habt es auf den Punkt gebracht, es geht uns um die Überschneidungszonen und aber auch irgendwie die Grenze, auch wenn wir uns gar nicht gegenseitig abgrenzen wollen, egal wie offen die Grenze ist trotzdem interessant, wann sprechen wir von unterschiedlichen Disziplinen. Und darum, um einfach diese Vorstellung möglich zu machen, habe ich eine Slide mitgebracht, um einfach einmal zu definieren, was sind Digital Humanities, weil es auch ein Begriff ist, der viel herumgeworfen wird und wo man sich mit den Definitionen durchaus schwer tut. Und so der grundlegendste Begriff, die grundlegendste Definition ist, dass es sich dabei um die Digitalisierung in den Geisteswissenschaften, aber eben auch die Reaktion der Geisteswissenschaften auf die Digitalisierung handelt. Deswegen hier als erster Punkt einer Definition von 4 Seiten der Digital Humanities, die ich einmal kurz aufmachen möchte. Der erste Punkt, die Digitized Humanities. Hier geht es um die Digitalisierung des Kulturerbes, sämtliche Artefakte in Vorfeldrepräsentation, 3D-Modellierung, digitale Editionen fallen hier auch drunter. Und das Stichwort hierfür wäre zum Beispiel Digital Cultural Heritage, das, was bestandshaltende Institutionen, Museen und so weiter machen. Dann gerne einmal weiter. Das zweite große Feld, was ich in dieser Definition aufmachen möchte, sind die Computational oder Numerical Humanities. Und hier geht es um die Erstellung formaler Modelle und Analysen, zum Beispiel mithilfe statistischer Verfahren, Machine Learning. Das Stichwort ist hier Data Science in den Geisteswissenschaften. Und Sie sehen hier schon quasi die Digitized Humanities als vielleicht notwendige Bedingung für die Computational Humanities, sind aber trotzdem damit verbunden. Noch einmal Klick. Ein eher übersehenes Feld der Digital Humanities, wo es aber viele Berührungspunkte gibt, das wären die Humanities of the Digital oder die Critical Digital Humanities. Und hier drunter würde die geisteswissenschaftliche Reflexion und Analyse von Phänomenen des Digitalen fallen, inklusive der Digital Humanities selbst, so zum Beispiel auch die Bemühungen um eine Theorie der Digital Humanities, was ein relativ junges Bemühen eigentlich ist, aber eben auch die traditionellere geisteswissenschaftliche Arbeit auf Born-Digital-Gegenstände angewendet. Sprich, was es zu Digital Humanities macht, ist die Arbeit am Digitalen. Und zu guter Letzt die Public Humanities, die Nutzung digitaler Ressourcen zur Wissenschaftskommunikation und Publicity für geisteswissenschaftliche Themen. Und wenn wir uns jetzt diese 4 Felder anschauen, stellen wir fest, dass wahrscheinlich die Digital Humanities in den meisten Fällen auf die oberen beiden Punkte eng geführt werden. Aber wir wollen hier für die Diskussion vor allen Dingen auch alle Seiten der Digital Humanities zeigen und deswegen die unteren beiden Punkte, die Humanities of the Digital und die Public Humanities, auch mit hineinbringen. Und ich glaube, hier sehen wir schon in allen 4 Feldern Überschneidungen zu den Informationswissenschaften. Das wird sicherlich noch deutlicher werden, wenn die Kolleginnen jetzt gleich auch zu den Informationswissenschaften sprechen. Ich möchte hier nur einmal ganz kurz vorausgreifen. Es ist sicherlich das Feld Computational Numerical Humanities, wo es heute die größten Überschneidungen zum Vortrag von Indira Sen gibt. Aber nur so viel zur Vorausdeutung und dann spiele ich den Ball gerne wieder zurück.
Gefangen, nehme ich sehr gerne an. Genau, Informationswissenschaft. Also traditionell betrachtet hat die Informationswissenschaft insbesondere ihren Ursprung im Bibliotheks- und Archivwesen, also viele sprechen dann auch von einer dokumentarischen, bibliothekarischen Wurzel. Der Ursprung macht auch bereits sehr, sehr viele Aktivitäten der informationswissenschaftlichen Disziplin deutlich, denn das Wissen, das eben in den Dokumenten, also zum Beispiel in Büchern verankert ist, musste in Katalogen erschlossen werden, repräsentiert, indexiert werden. Und auch die Aktivität, die Suche, ist eben in nicht digitalen Katalogkarten bereits auch ein Thema gewesen. Aber nächste Folie bitte. Natürlich wachsen wir alle mit der Zeit. Wir bekommen neue Technologien oder die Technologie entwickelt sich einfach auch rasant, die Digitalisierung und natürlich auch Veränderungen innerhalb der Gesellschaft und auch Anforderungen an die Gesellschaft formen aber auch tatsächlich die Disziplin der Informationswissenschaft. Und wir sind heutzutage umgeben von ganz vielen Informationssystemen, aber auch Informations- und Kommunikationssystemen. Also neben Suchmaschinen, einer der bekanntesten, also Google, spielen aber auch insbesondere Social-Media-Dienste, also angefangen bei Facebook, Twitter, zu Livestreaming-Diensten, Reddit und viele mehr eine immer wichtigere Rolle. Und deutlich wird hier also auch, dass die Informationswissenschaft nicht nur sich mit den textuellen Dokumenten beschäftigt, sondern eben auch mit nicht textuellen, also auch hier angefangen von Audio, Video bis hin zu Bildern. Und ganz wichtig ist aber auch, und das sollte man auch betonen, nicht textuelle Dokumente hier in diesem Kontext sind tatsächlich auch Museen, Galerien, wirtschaftliche Gebäude. Also es ist nicht nur, wie gesagt, in Social Media zum Beispiel Audio und Bilder. Nächste Folie bitte. Genau, und hier sieht man es eigentlich nochmal ganz schön auch plakativ, dass eben die Informationswissenschaft durch 3 verschiedene Aspekte wiederherum miteinander verzahnt ist. Und Sie sehen eben, es ist einmal die Technologie, Informationssysteme, generelle digitale Systeme, die einen Schwerpunkt bilden, der Mensch, die Gesellschaft und aber auch eben letztlich die Objekte und hier eben wieder natürlich digitale, nicht digitale, textliche, nicht textliche. Und diese 3 Aspekte sind miteinander verzahnt. Und wenn Sie sich die nächste Folie auch anschauen mit ein paar Beispielen, und dann wird es, glaube ich, auch wieder ein bisschen greifbarer, insbesondere die Dimension Mensch, Gesellschaft, Informationssystem. Hier sprechen wir von einer Mensch-Computer-Interaktion, von der Akzeptanz. Also wie harmonieren eigentlich diese 2 Dimensionen miteinander? Sie sehen aber auch unten im Dreieck Mensch, Gesellschaft und Objekt, bleiben wir bei Informationen, ja? Dann sprechen wir insbesondere von Informationskompetenz, also wie gehen wir mit Fake News um, erkennen wir Fake News zum Beispiel. Und Sie sehen aber, und das hat auch Stefan vorhin schon erwähnt, noch eine dritte Dimension, die eben mit Informationssystemen zum Beispiel und auch wieder den Objekten, und hier geht es insbesondere auch eben unter anderem darum, Machine Learning, künstliche Intelligenz, aber auch generell einfach die Informationsverarbeitung, ja. Also wie werden eigentlich Informationen auch in Systemen dargestellt und wie kann man damit auch arbeiten, ohne dass jetzt per se der Mensch, sage ich mal, davor sitzt. Und dadurch kriegt man hoffentlich natürlich auch ein sehr gutes Bild davon, was eigentlich so der Kern in ein paar Worten der Informationswissenschaft sind.
Ganz genau und ja, vielen Dank schon mal für die ganz allgemeine Erläuterung. Ich werde daran jetzt noch ganz kurz abschließen in dem Sinne, dass eben auch ein Teilgebiet der Informationswissenschaft die Infometrie ist. Und die Infometrie, das ist ein Begriff, den gibt es schon etwas länger, der wurde von Blackard und Siegel, aber auch von Nacke, ja, unabhängig voneinander geprägt in Deutschland, und ganz, ganz allgemein geht es dabei um die Analyse von allen quantitativen Aspekten der Information, egal in welcher Form. Also Sie haben das ja gerade schon gehört. Es können ganz unterschiedliche Anwendungsfälle in der Informationswissenschaft gibt es oder können auch anfallen, und die Information selbst kann ja auch in ganz vielen unterschiedlichen Ausprägungen eben dargestellt werden. Und ein Unterbereich davon oder als ein Unterbereich davon kann man eben auch die Analyse von Social-Media-Metriken sehen, die dann dementsprechend auch als Teil der Infometrie einzuordnen ist. Also zum Beispiel, wenn ich mir als Person anschauen würde, wie auf Twitter zu einem bestimmten Thema getweetet wird und wie oft das geliked und geteilt wird. Und das bringt uns auch wieder zurück zu unserem heutigen Vortrag mit Indira Sen. Und at this point, I will also switch to English language because today our presentation by Indira will be held in English. And yeah, again, Indira, then I'm very happy, we are very happy to welcome you here today and to hear your talk today. And yeah, with this, I guess I have not so much to add at this point. We will have a short change with the slides and then also directly start with you, Indira.
Perfect. Thank you so much, Isabelle. Let me just share my screen.
Yes.
Great. And let me go into presenter view. Okay. Can you all see my screen?
Yes, we can see your screen, but is this the title page? Yes, it is a title page.
This
right?
should be the starting page. That's fine.
Perfect. So then I will also mute me and I will forward the talk to you, Indira. And yes, we are really excited to hear you today.
Great. Thank you so much, Isabelle. I'm very excited to be here. And especially now that I've heard the introduction of all the different disciplines involved in this series. And I'm going to do a bit of a soft start to this talk by looking at some of these recent headlines about artificial intelligence. And you might be thinking, what does this artificial intelligence related stuff have to do with the topic that we just saw about information science or digital humanities? But I hope it becomes obvious as the talk goes on. So the first headline is about using artificial intelligence for deception detection or to detect lies. The second one is about using artificial intelligence or AI for platform governance or content moderation, where the idea is that artificial intelligence would automatically find and flag problematic content on social media platforms like Facebook or Twitter. These would be the type of content that are harmful or goes against the community guidelines of a particular platform, and surface them for people to detect them and maybe even remove them. And finally, another recent headline, which is quite recent, from a month ago or so, which talked about using artificial intelligence methods to identify mental health issues and disorders from people's speech through voice analysis. And all of these headlines make me think that these are some rather futuristic uses of artificial intelligence, and makes me think about this particular question, which is, what can artificial intelligence in combination with big data tell us about social behavior? And I bring up big data over here because artificial intelligence often harnesses large-scale data sets, which are either from traditional sources or often social media data, to train methods. And these types of data can also represent a lot about human behavior. And so we have this combination of big data and artificial intelligence for a lot of social research. And to be a bit more specific, I want to focus on one particular type of big data source, which are digital trace data obtained from digital platforms like social media platforms or web platforms or even apps, in combination with computational techniques, as opposed to, say, manual analysis. And I'm wondering what this combination of digital traces and computational techniques can help us learn about social behavior. And that's the gist of my talk today, which is more formally about measuring psychosocial phenomenon, for example, emotions or mental health disorders or problematic content from digital trace data, and what is hopefully a critical reflection on that. And I'm going to kickstart things by talking about the main thing that facilitates this type of research, which is data. And there are many different sources of data for social sciences and for research in the social sciences. And I've categorized them into three types: surveys, experiments, and observational data. But of course, we can also have their combinations, for example, experimental surveys. And then we have their digital counterparts, so digital surveys or digital experiments and digital observation. And today I'm going to focus on two types of data specifically: surveys and online or digital observation. And what are these digital observations? They are often called many names, for example, digital behavioral data or found data, but essentially these are data documenting the interaction of users who are on digital devices or services, such as a social media platform or an app on our phone. And that is contrasted with surveys, which are typically a collection of information from a sample of individuals, usually when they answer a particular questionnaire and fill out their responses. And again, going back to digital traces, I want to focus on this infographic, which is a bit outdated now, but it's from 3 years ago or so, in 2019. And what this infographic represents is the amount of data that is generated every minute on a variety of social media and web platforms. And the notable thing here is that this is a lot of data. And one of the advantages of this type of data is its large scale, as well as its velocity, that it's being generated very rapidly. And these are all contrasted with survey data. And given the velocity, one more advantage of this type of data is that it allows us to measure immediate responses or reactions, especially to acute events. Whereas for a survey, we would have to wait for some time to get these reactions. And therefore, this data has a lot of advantages, scale being one of them. And because this data is available at such large scale, it can be difficult to manually analyze it. So for example, it can be difficult to manually code it. For example, how one would do in qualitative analysis or surveys. And therefore, we often rely on computational methods which do automated or semi-automated analysis of this type of data. For example, techniques like machine learning or natural language processing, which are especially designed for textual data. And in this slide, I have a few interesting research papers that work with this type of data, just to show you how, just to show you the innovative use of this of digital traces. So, for example, in 2010, O'Connor and colleagues used Twitter data to predict election outcomes as well as approval towards presidents. And this more recent work by my colleague Sebastian Stier, who is working on combining surveys and digital trace data to get the best of both worlds. The idea very much here is that the traditional social sciences, as well as computer science, which has looked at many of these computational methods, are finding common ground based on these new types of data. And often, many people say that this type of data has created a revolution in the social sciences and given rise to entirely new disciplines or fields or even subfields. And computational social science can be thought of one of them. It's often described as a 21st century science, with the metaphor that is typically invoked is that of a telescope. Now, the telescope allowed, the invention of the telescope allowed us to do data-driven studies of the natural world. And the hope is that digital traces in combination with computational methods would give us a telescope for the social sciences by allowing us to do data-driven studies of the social world. And this is all to tell you that digital traces have a great deal of potential and can help us learn about many different things, some of which that Isabelle, Stefan, and Aylin touched on in the introduction about socio-technical platforms or cultural analytics in digital humanities, as well as other aspects like the quantified self or learning about psychological, social, or economic phenomenon in general. And I want to particularly highlight two studies in this context. The first, which is about predicting elections from Twitter for the German political landscape using a technique called sentiment analysis. And another paper for detecting influenza epidemics using search engine query data, with the innovative premise that when people are looking for search or searching for information about influenza, it might be an indication that they themselves are experiencing symptoms of influenza. And I'm sure all of you would agree that this is a rather pressing application given the current pandemic. And so these are two studies that show us this kind of potential new uses or repurposing of digital trace data for social research. But the reason I bring them up is that digital traces are not free of pitfalls. Follow-up work of the first study about Twitter elections showed that the Twitter data actually predicted that the Pirate Party would win the German election because it was rather popular on Twitter. However, we know that that did not come to be, and they did not win the election. And on the other hand, what happened with the Google search engine queries is that after one point of time, the initial results were quite successful. There was a high correlation between what the system was predicting and the actual flu rates or the influenza rates. But as time went on, people started being interested in searching for information about influenza for other reasons, because it was driven by a media coverage. And especially now, people might be interested in just knowing about what's happening about the COVID-19 pandemic. And so these search engine results were no longer about a person just having the flu, and therefore the system highly overestimated flu rates. And this is problematic for several reasons, because if we use this type of inferences for policy making or infrastructure design, we need them to be accurate. And when they are not accurate, we can have a lot of issues. And that brings me to the next problem, which is that just because the data is bigger, it doesn't mean that it's better. And a lot has been written about this. For example, Zeynep Tufekci writes about the heavy focus on Twitter data for social media analytics, and how this focus can often lead to misleading generalizations to other social media platforms, or even beyond social media platforms, to the social realm in general. And Oltiano and colleagues have written extensively about the different biases and pitfalls that can occur when using digital trace data or social media data at every, and these biases are linked to each stage of the data handling pipeline. And Andreas Junger talks about the need for a measurement theory for digital trace data that would allow us to make accurate inferences using this type of data. And while the data themselves have several issues, there are also issues with the computational methods that are used to analyze this type of data. These methods themselves are often data-driven and trained on large-scale data sets of social media or web data, and they are often black box and intransparent in nature, where their predictions are difficult to reason or explain. And recent work has shown that many of these techniques themselves tend to perpetuate social biases. So this recent paper by Kaliskan and colleagues shows that many natural language processing techniques or language technology tend to encode human-like biases, particularly gender bias or racial bias, which then percolate down to downstream tasks and can cause several biased outcomes. This naturally gives us rise to two sets of questions. How can we make research with digital trace data more valid and reliable, as well as more transparent? And additionally, how do we improve the communication between the different disciplines who work with digital traces, as this is quite an interdisciplinary field where people might have different backgrounds and different entry points? And to do that, we might take some lessons from the traditional social sciences. And for that, we're going to do a quick rewind. And we're going to talk about the total survey error framework, or the TSE. The total survey error framework is a tool that helps us systematically identify and characterize errors in survey data. And errors are linked to each step of the survey lifecycle. So this is a diagrammatic representation of the total survey error framework, and that was presented by Groves and colleagues. And there's a lot going on in this image, but I'm going to focus on a couple of things and maybe talk about the starting point, which is that we start off with a construct and a target population. The construct here is what we are interested in measuring. It could be something like as simple as someone's height, or something a bit more complicated, such as gender bias. And the target population is the population that we're interested in measuring this construct in. So that could also be something simple, for example, a national population, or something a bit more complicated, for example, the population of migrants in a particular country. And we measure the construct and the target population through a survey, and we take all of these different steps while conducting a survey, and then end up with the survey statistic, which is our final estimate of the construct. And what's really nice about the total survey error framework is that it describes all of these steps in a survey lifecycle and identifies and describes errors that are associated with each step. And the other really nice thing about the total survey error framework is that it not only describes the errors, but it also categorizes the errors based on their source so that we can be more careful and understand their origin. And the two types or the two sources of errors that it describes are measurement errors, or errors due to how the construct is defined and operationalized, and representation errors, or errors due to our target population or who we are actually measuring. And to give you an example of the type of errors that we have in the TSC, I want to mention the coverage error. And the coverage error is the difference between the target population and the sampling frame. Now, the target population, I already told you, could be, let's say, the German national population. And the sampling frame is how I access this target population. I have limited resources and I can't survey everybody in Germany, so I need to find a way to reach out to a sample of them, or a smaller subset of such people. And one way to do that is to rely on a sampling frame. And one typical example of a sampling frame is a phone book. The idea is that the phone book lists a bunch of people, and it also tells me how I can reach out to them. And then using this phone book, I can call people up and ask them to fill out my survey. And this is quite nice. However, there are some issues in the fact that many people might not want to be listed on a phone book. Many people inadvertently are not listed in a phone book, and some people might not even have phones. And these are the reasons that make the sampling frame different from the target population. So it's not a one-on-one match. And this difference leads to a coverage error because I'm not able to access the exact target population that I want, but a proxy of it, and a rather imperfect proxy of it. And the goal of the total survey error framework is that it helps survey designers reflect on their design choices and think about mitigation strategies for future research as well. And the whole reason that I bring up the total survey error framework in this context is that it gives us this way of reflecting about the errors that we can make when doing social science research, at least when we're using survey data. So now that we have this nice framework for understanding the reliability and validity of our research, as well as for identifying issues, how about we just directly apply this to social science research with digital trace data? So this is a question that I pondered with my collaborators, and we thought that we came to the conclusion that that's not possible simply because of the fact that digital traces and survey data have several differences. The primary of which is that digital traces are passive. There's no solicitation of responses. In a survey, you would typically go out and ask somebody some questions about their height or how they feel about female political candidates, but we can't do that when we have social media or web data. And on the other hand, given that this data is generated on these platforms, the platforms themselves have several effects on user behavior. This One example could be due to the recommendation systems suggesting certain things, and recommendation systems are pretty much ubiquitous on all platforms. And finally, going back to the whole idea of using automated methods for this large-scale data, and I already touched upon some of the issues with these automated methods in terms of their social biases. These are also factors that we need to take into account when thinking about research with digital trace data. And so these are just some of the examples that make us think that digital traces have certain idiosyncrasies which are not covered by the total survey error framework. And so how do we actually do this then? How do we carefully identify and document potential issues in digital trace data, knowing that they have certain differences from survey data and we cannot use existing error frameworks on it? So this is what I worked on along with my colleagues in trying to unpack errors in digital trace data, and that led us to conceptualize the total error framework for digital traces of human behavior on online platforms, or the TED-ON. And this is the visual representation of this error framework. And again, like the TSE, there's a lot going on, but we're going to take a bit more time and go through this a bit more in detail. But I would like to start again that there are many commonalities with the TSE, because we were inspired by the total survey error framework in designing this framework. And we also start with a construct and a target population. But instead of a survey life cycle, we now have an idealized pipeline for doing research with digital trace data that also starts with construct definition and goes up to data analysis, where we come up with the final estimate of interest. And like the TSE, we also adopt this differentiation between measurement errors and representation errors. So on the left in yellow, we have the measurement errors, and on the right, we have the representation errors in blue. And like the TSE again, we have errors linked to each step of the idealized computational social science pipeline, or the pipeline that uses digital trace data. And I want to go through this error framework with the help of a case study about presidential approval, and especially measuring presidential approval from Twitter data or tweets. Now, why were we interested in presidential approval? Presidential approval is actually quite an important construct in the social sciences, especially in political sciences and political communication, and not just for scientists, but also journalists, public officials, even campaign managers who want to see how a particular president or even other politicians might be doing in the light of in the public's eyes. And from a research perspective, social scientists are often interested in presidential approval, especially in times of crisis, for example, wars or armed conflicts, when in the past it was seen that presidential approval tends to spike because there's what is described as a rally around the flag effect. There's an outpouring of support and trust for the president as they deal with that particular crisis. And so it's something that social scientists are interested in researching also from a theoretical perspective. And why do we want to do this with Twitter data? One of the reasons that I use this case study is because this is rather an evergreen case use case that has been studied for some time now, including with this paper that I already mentioned by O'Connor and colleagues, who not only use Twitter data to predict elections, but also to try and understand presidential approval at that time about Barack Obama. And since then, there have been several follow-up studies, with this more recent study in 2019 by Josh Pasek and colleagues, who discuss how Twitter approval and survey approval correlate or don't correlate, especially as time goes on. And before diving into this case study about using Twitter data, let's talk about how presidential approval is typically studied using surveys. We have this survey question, which is quite simple and straightforward about whether the respondent approves or disapproves of the way a president is handling their job as a president. And for this case study, I'm going to focus on Donald Trump, the former president of the United States, because he was rather a notable president. And so in this question, we have his name directly plugged in. And the idea is that this question is given to a set of people. This is supposed to be a representative sample of the national population. And their responses to this question are then aggregated to find a daily approval measure. And this is done every day so that we have daily measures of approval to see how it rises and falls. And let's say we want to do this with social media data, specifically Twitter data. And we're going to follow the pipeline that we discussed before and start off with construct definition. Now, the construct of interest is presidential approval, and a researcher, even without thinking about concrete steps for data collection or data analysis, they might start brainstorming and thinking about how they can operationalize or actually measure the presidential approval construct with Twitter data. And the idea over here is that they might think that a person who has a Twitter account, they go on Twitter and they express their opinions about Trump. And so it could be a tweet like this, where the person says that they voted for Trump, but they regret that decision now. And a researcher might think that tweets about Trump with positive or negative sentiment or opinion is equivalent, or at least a good proxy for the survey question that we saw before. However, I want to focus on one aspect of this survey question, which is the last part of it, which explicitly focuses on the president's job as a president. Tweets about Trump may be related to his personal life or his business life, and they might be indirectly related to presidential approval, but they are not about how he is handling his job as a president. And even without going into concrete steps of data collection and data analysis, we run into the issue of validity. Validity is the gap between a clearly defined construct, in this case, presidential approval, and the envisioned measurement that we can do, which in this case were tweets about Trump with positive or negative sentiment. And because of how we are mismeasuring the construct of interest, this is a measurement error. The next step is platform selection. And in this step, for a general research study for computational social science, a researcher might think that they want to select a particular platform, or maybe even multiple platforms for data collection. And in this case, it's pretty simple because we're going to look at one platform, which is Twitter, which is also nice because the data is easily accessible, and Twitter makes it easy for academics to access their data. However, it's not always that simple. So this is a tweet that I was making just before this talk. And if you look closely at this tweet, it actually highlights a part of it in red. And maybe those of you who are familiar with Twitter already know why this is the case. That's because Twitter has a character limit on the tweets. And this limits how people express themselves and forces people to write short and terse posts. In fact, there was some research that showed that when Twitter changed from 140 characters to 280 characters, people were more permissive and more expressive when writing content. But the whole idea here is that platforms have affordances. For example, the 280 character limit, or even something like community guidelines or recommendation systems, which affect how people behave on these platforms. And these affordances can distort how people express themselves or the expression of traces, and therefore distort our measurement. And this is a platform affordance error, which is the gap between the true traces that we want to measure and the traces that are distorted due to platform affordances. And because this is a mismeasurement of our construct, this is also a measurement error. But when we're doing platform selection, we're not just affecting the measurement, we are also affecting the representation or our target population. Implicitly, we are selecting a set of users or people who we are studying. And in this case, that's the platform population or the people who have Twitter accounts. This recent, and that would be fine if the people with Twitter accounts or Twitter population was the same as the American population. However, this recent research by the Pew Research Center showed that American users on Twitter tend to be younger and they lean more democratic. And therefore, Twitter isn't really a good representation of the national population. This is especially true for other places like Germany, where there aren't many people using Twitter compared to, say, Facebook. The problem here is that different platforms attract different demographics. And that can lead to a platform coverage error, very similar to the coverage error in the total survey error framework. But this time, it's the gap between the target population that we want and the platform population that we end up getting. Because our platform in this case is our sampling frame instead of a phone book for a survey. Now that we have done construct definition and platform selection, we can actually get into the research and start doing some hands-on stuff, starting with data collection. And a reasonable choice to do data collection over here would be to use a keyword, let's say Trump, because I'm interested in tweets about Donald Trump. And that would give us tweets like this. You already saw this tweet a few slides ago where the person states that they regret voting for Trump now. On the other hand, it could also give us tweets like this, which is about the Trump Tower. However, it's not the Trump Tower in New York City, which is associated with Donald Trump, but a Trump Tower in some other place. The problem here is that even when, just by using this keyword does not guarantee us that we will get tweets or posts that are only about Donald Trump. We can have such noisy tweets which are not at all related to him. And that is causing a trace selection error, or the gap between the ideal response that we would like and the traces that we end up collecting due to our keyword choice, which could be noisy and also leave out some important data. And when we do this data collection, we don't just affect measurement, we also affect representation. And why is that? So here is a tweet that's about Donald Trump, and it says that the user says that they would like for the next president to not abuse their power. But they don't refer to Trump using the keyword Trump or say Donald Trump. They instead use the word Orange Cheeto, which many in the American context would be familiar is a nickname used for Donald Trump in a rather derogatory or negative manner. And if we don't have such keywords in our data collection, we would be missing out on such tweets. And that's problematic from a measurement perspective, but it is also problematic from a representation perspective, because this is not a random error. This error could be systematic, and in this context, it is systematic towards people who are critical or detractors of Trump. And if we miss out on them, our data is no longer representative of the target population. And we have what is called a user selection error, or the gap between the platform population that we selected in the last step and the users who are chosen due to our keyword search. After data collection, we move on to data pre-processing. And in this step, we might do many different things. Oftentimes, there's not a very clear separation between data pre-processing and data analysis. But one thing that is quite recent and gaining some traction in social media research is automatically inferring demographic data. And let's contrast this with surveys. In a survey, you would typically ask somebody for their demographics, for example, their age, gender, or their ethnicity, or their location. And this type of information is quite important for several reasons, and especially in the context of presidential approval, because you might want to disaggregate your data and learn among which demographics Trump is performing well, which demographics dislike him. For example, do younger users like Trump more as opposed to, let's say, Republican users? And so this information is quite valuable, but unfortunately very difficult to get from these passive social media traces. Many people on Twitter will not have their demographics on their Twitter profile. And one solution to this is to use automated methods or artificial intelligence methods to infer this. These types of methods often rely on image analysis or computer vision. However, recent work has shown that these methods, especially commercial methods for doing gender classification, is quite error prone. And again, these errors are not randomly distributed, but they tend to be especially high when inferring the demographics of people of color. And in this work, it was shown that it was especially bad for Black women. And this is what we call a user augmentation error, or the gap between users chosen due to the keyword that we selected in the last step and the users for whom demographics can be inferred in this step. Another thing that people often do while doing data pre-processing is to remove bots. Now, bots are a rather controversial topic on Twitter. Many people say that that Twitter is basically overrun by bots, and bots are doing many nefarious activities, especially information warfare, spreading misinformation, or skewing the opinion towards certain candidates or political factions. And so it seems reasonable that we would like to remove bots from our data because that is not organic, and it's going to misrepresent our political approval measure. However, detecting bots is difficult, both automatically or manually. In fact, this interesting paper conducted a study with people and showed that people often label another profile a bot simply because that profile does not agree with them. And the problem here is that if people have such a hard time finding bots, automated methods could also struggle with it. And generally, there's no kind of ground truth to evaluate some of these automated methods. And that leads to a user reduction error, which is the gap between users for whom demographics can be inferred and the users who end up being categorized as humans, with the humans in quotes simply because we don't know how accurate these methods, be it automatic or manual, for detecting bots are. And the last step in this pipeline is data analysis. In data analysis, we might want to come up with the final estimate based on daily approval measures or daily sentiment. And there are many ways that we could do this. We could count the normalized positive words in a day, the ratio of positive and negative words per tweet, add all the ratio of all tweets in a day. So to give you an example, it could be that I say something negative about Trump in the morning, but then say something positive about him in the afternoon. So how do I then aggregate this? Does that mean like my net approval for Trump is neutral? And so these are some of the design choices that a researcher is faced with. And different aggregation methods can lead to different measures of approval. And this causes a trace measurement error, or the gap between the true measure of presidential approval and the aggregate measure that we obtain based on our design choices. So that was a quick summary of the error framework. I couldn't cover all the errors due to a lack of time, but this paper is available open access in Public Opinion Quarterly. So I encourage you to have a look about the detailed errors and their examples, as well as some suggestions on how to mitigate some of these issues. But the big reason why we have error frameworks in the first place is so that they can help us identify sources of errors, not just due to the data, but also our design choices, and help us communicate and document them. And I'd like to start wrapping up this talk by focusing on something that we've not touched upon yet, which are research ethics. When we talk about errors, we don't think about it from an ethical perspective, but research ethics are very important. And given that this is a rather recent area, the discussion on research ethics is still ongoing. And there's a focus on privacy, especially on the lack of informed consent. So this paper by Casey Feisler and Nick Proferis surveyed many of the Twitter users and asked them how they felt about their tweets being used for this type of social research, and found that often there was some discomfort based on the context of the research. And there's also the big issue about automatic inference, especially when we think about gender inference and how that can be quite ethically fraught, because people might not like it if you infer someone's gender without their consent. And so these are just a few of the ethical issues that surround work with digital trace data and computational methods. And I'd like to end this talk again by emphasizing that digital traces are not automatically better than survey data, and they are not also a panacea that is going to solve our issues in social science research. Error frameworks can help us critically assess some of these issues and document limitations, implications, and consequences of what is available to us, as well as our design choices. And to leave off in a somewhat optimistic note, instead of being really pessimistic about research on this area, there's a great deal of super meaningful, interesting, high potential research that we can do. And the way to be careful about this is to have a focus on documentation, showing our work and our assumptions, thinking about a human-centered design by considering different stakeholders and subjects, for example, the people in our data, as well as focusing on reflexivity and introspection on our own perspectives, as well as our design choices. And so to end, I'd like to go back again to the idea of the telescope that digital traces give us. And this is this could be a telescope for the social sciences that allows this type of data-driven studies, but we need to calibrate this telescope together, especially with an interdisciplinary focus. And with that, I'd like to thank my amazing collaborators on this work, Katrin Weller, Claudia Wagner, Fabian Floek, and Bernd Weiss. And thanks to all of you for listening. And I would love to know your thoughts about potentials and pitfalls of using digital trace data for social research.
Yes, thank you very much, Indira. Thank you very, very much for your talk and also for all the explanations. And I guess with this, we have really a lot input for our discussion round. And yes, so maybe my first question would be if there are any questions at this point, also from you, maybe Stefan, or from you, Aylin.
Maybe we should start while waiting for the live stream to catch up because they are a bit delayed. And let me be the one starting off with I don't have a question but a comment, but this is kind of a tradition in talks. No, I'm really it was a really interesting talk, and I'm really still thinking about everything you said because let me just briefly speak from digital humanities perspective. As I pointed out on my slide, the discussion about theory for digital humanities is rather young, and I think digital humanities are still unsure what traditions, what research traditions, what subject traditions they should look to when being inspired for the theory. And I think that what you presented to us could be a big inspiration for digital humanities, because I see big commonalities between the studies you presented and digital history, for example, because we also deal with historical traces, and we measure historical actions from sources indirectly. And the funny thing is, you are dealing with historical traces, albeit with very, very recent ones, but it's always kind of this historical perspective. And I also see commonalities between systematical errors you pointed out as user selection and platform selection, and archival strategies, for example, that influence how we view historical facts, historical history itself. I don't know. Would you feel comfortable if someone pointed out that there's this big commonality between the research you pointed out and historical research? Is there anything you would like to add to that?
Yeah, I think that's a very interesting perspective, and I think I find myself in agreement with you. I think from a digital humanities perspective, like some of the work that I know about are also in things like cultural analytics, and I think one big source of data there is also the Google book corpus, I believe. And I think that there were, or like maybe I think the Google Ngram analysis as well for that. And I remember there was this very, very cool study about trying to understand how the socioeconomic status can be measured from this type of data and how it changes over time, especially related to different words. And I mean, that was very interesting and innovative. But however, like it had like some of these issues that you pointed out about user selection, because many of these books were written by a certain demographic of people, for example, men, often because, or even if it was women, they were often under pseudonyms, and so simply because of the historical context about who had access to education. And in that sense, we also have to think about whose socioeconomic status or whose perceptions are we measuring from this type of corpora as well. So that's just one example, and I know that there are some really cool people who are doing work in the kind of intersection of humanities and using computational techniques. For example, Lauren F. Klein, who wrote the book Data Feminism, and she does some work about understanding Civil War related issues. So this is like the Civil War in the US context, and analyzing those papers and content from those times, but also trying to see who was left out, for example, often again, women, Black women, and trying to find other resources that integrate their perspectives as well. So yeah.
Thank you very much.
Yeah, thank you. So maybe at this point, I will also sneak in with another question to you, Indira. And as you told us during your talk, there exists a lot of passive digital traces. In your case study example, also a lot on Twitter. And you also showed us really clear what can be problems, what can be errors, and also what can be things to consider. And also especially some things like, for example, the coverage of the population and so on. However, also in terms and maybe in interest of our audience, would you also like to shortly describe or sketch a little bit why Twitter is, despite a rich resource for research?
So if I understood correctly, like what makes Twitter an attractive platform for social research?
Yes.
Yeah. Yeah. Yeah, I mean, that's a super relevant question. And I think I tried to touch upon some of these issues. And maybe one perspective I want to bring out now is that I contrasted digital trace data research with survey data, but I do want to say that survey data-based research is also not perfect. Surveys historically now, especially more than ever, have apparently historically low response rates in the sense that people just don't want to fill in surveys, and there is this big problem with representation also, because if so many people are not responding, and if there's a very certain systematic group of people who are not responding, like, I don't know, teenagers or young people who just don't want to pick up their phones, what that could also affect our results. And on the other hand, social media has several of these advantages. Like Twitter, for example, has this great advantage that it's much more immediate, right? Like, for example, we have this war going on in Ukraine, and for a survey-based response, we would have to fill this survey, find respondents, analyze it, and it would take slightly longer. Whereas if I just look at some tweets and I start analyzing them, I could get a more immediate response to the war. And this was also true during the pandemic, when I believe Facebook teamed up with certain universities to have like surveys on their own platforms. And this was not representative, but at least it gave us the opportunity to do this very early on, when the information about the pandemic was still evolving, and it was important to kind of get the news out and get responses in as quickly as possible. So that's, I believe, one big advantage of social media data. And the other advantage is just as you said, right, how rich it is. Because if you look at the survey question, now I have to do this thing where you have to see all my slides, but yeah, so if you think about the survey question, it's quite binary in this case. Do you approve or disapprove of Trump? You could, of course, get a more detailed response, but that would be more expensive because you're taking more time from the respondent. But on social media, if you look at this tweet, it's much more detailed. It's where somebody almost says why they now regret voting for Trump. So this person has, I believe, a Russian flag in this. So they are making this comment about the Russian information warfare and associations with Putin. And so there is much more richer information here, and which could give us clues about why a person thinks the way they do. And that's also another advantage of social media, which is that perhaps it's not representative, but it can still give us a few starting reasons or hypotheses that we could test out in a more representative sample, say through survey. So I'm a big, also like an advocate for like kind of combining these data sources in innovative ways.
So maybe while the slide is also displayed, so I got a question, Indira. So you said, and I totally understand that, and I'm agreeing with you that such a tweet has much more information than, for example, a survey like yes or no, which is very binary. And I would like to link a little bit on the question that Isabel stated. So why Twitter? What are the the advantages of Twitter? And now I was thinking about, okay, Twitter has a limited possibility how much you can write, but what about, for example, Reddit or Facebook posts where you can write a lot? And now I'm thinking about the technical side, so the system that needs to understand. And I mean, we are humans, so and one time we can say something and are smiling, and maybe it was something mean, you know? And now my question is, so is this also the case, like not more data is better, like not much more information is also better? And are there maybe platforms where you would say this is still challenging to, from the semantic perspective also, to get answers?
Yeah, I love that question. Thank you for that. I agree with you. I mean, these things are quite complicated, right? Like, as you say, this idea about saying something mean while smiling, there is this problem of sarcasm and irony, which again, like people struggle with. So if people have a hard time detecting this sort of thing, how can we expect machines to do a good job? And in general, the kind of the research on sarcasm and irony detection through computational methods is still kind of ongoing and still not exactly even close to human performance, let's say, even though human performance is itself probably not the best benchmark here. So yeah, we have to kind of figure out these intricacies. And in that case, I think one thing that helps is context. And now context can mean many different things. It could be the kind of the person that you're talking to, you know, like the kind of the discussion context. So, and you mentioned Reddit. And so one nice thing about Reddit is that we have these threads and or these discussion threads where you see what was said before, what was said later, and so you can go into all of that. Now, context could also mean the community the community's kind of guidelines. And again, on Reddit, people often have very specific rules depending on the subreddit that they're talking in. I think there was this really nice study about sentiment analysis from subreddit, where they saw sentiment on football subreddits versus feminism subreddits. So in feminism subreddits, if you say soft, that has no negative connotations. But if you say soft in football, it typically means that you're describing a player in a negative light. And so the idea of that paper was that they create these like domain specific dictionaries or sentiment analysis methods. And so that's also another source of context. So I definitely agree with you that there are these semantic challenges, but I guess like because there are these challenges, there's also a lot of potential to innovate and find new ways of making sense of the conversation here. Does that kind of make sense?
Yes, absolutely. So thank you for answering my question.
Yes. I would also, or I have also another question to you, Indira. So as we also slightly talked about it, you also talked about it in your talk, there is a difference between bots and also human users. And also in terms of the population, is there already a big difficulty to distinguish between the human users and the bots? And maybe what is your personal perspective on the future according to this topic?
Yeah, that's also a really important question, especially in the Twitter context. I'm not a expert and I don't work so much on bot detection, but I have some colleagues who have been exploring this, and I'm just going to maybe borrow their comments on this, which is that one of the reasons that this is a hard problem is because of the lack of ground truth data, because if you have a method to detect bots, you need to be able to evaluate that method. And for that, somebody else needs to decide whether something is a bot or not. And that's just tough. And that's why we have this paper which showed that people often just label other users bots if they simply disagree with them. And so maybe that tells us more about the person doing this labeling rather than the bot. So that's one big problem. And the other problem is that even, let's say, I have a sophisticated method for detecting bots. The problem is that this is quite adversarial in the sense that if I was a bot designer, or if I was like, let's say, a malicious actor who is putting bots all over social media, I would learn about this detection method and see what type of techniques they rely on, like which features they use. For example, this account tweets 50 times in a minute. And I would then change my behavior, or I would change the behavior of my bots to bypass that. So it becomes a bit of like a whack-a-mole issue that like I hit one bot and then one more evolved bot comes up. So it's a problem that's difficult to solve in the long term. That would be kind of my perspective, unless we are more clear about what bot means. And I think Twitter especially has been very transparent about these issues, and I think the recent terms of service state that they allow bots if the bots are actually saying that they're bots. So these are not deceptive bots. So there can also be useful bots, right? Like people who bookmark your tweets or do the thread unrolling. And so there are these useful bots, and as long as somebody is, or a bot is clear that they're a bot, they are allowed. So there are these kind of intricacies also involved in bot detection.
Yeah, thank you. And also the last aspect you mentioned is really something which also came to my mind, like, oh, wow, this is true. Sometimes, or in this case, bots already say they are bots. And this would be especially helpful then also for research. Yes. Yeah, so I don't know, Aylin and also Stefan, do you have a further question maybe?
Let me maybe just ask a naive question when it comes to bots, just in general. Of course, I know that bots do distort your data, but could one make the argument that one should include bots, at least to a degree, maybe in your research, because they do shape the public discourse on Twitter? So how could one take that into consideration, as in what do we measure if we measure Twitter? Because if we wanted to really grasp what Twitter is like, we do have to include those bots. So would that be a strategy to say, okay, I don't know how, or I don't really. Let's not talk about so much about how Twitter represents the population I'm interested in, but let's have a look on Twitter itself. But maybe that wouldn't be a question that that social scientists asked. But I don't know. Maybe if you're interested in cultural analytics, so to what degree could one or should one include bots in analysis?
Yeah, that's super interesting. But I also think quite hard, and maybe that kind of made me think about what was one of the rather the kind of the suggestions for doing computational social science, which was kind of going back to really thinking about why we want to measure things in the first place. So I think that maybe that's associated with what you're saying, because I mean, whether we like it or not, bots are there and they are shaping public opinion. And so if we want an accurate representation of Twitter, then of course we should not exclude them. So yeah, I definitely agree with you over there. And in this sense, maybe it again helps to think about why we want to measure presidential approval. I can see the case for including bots to say that this is how the public opinion has been shaping by whichever actors, but this is like the Twitter public opinion. And on the other hand, if you want something where you want to replace surveys with Twitter data, then you don't want the bots in there, because you want to know what people are saying, like what the people who can actually vote later on. Another reason, like many people say, is that like, oh my God, these exit polls, they are so bad. They are always saying wrong things. Let's replace that with social media data maybe. And so in that case, you don't want bots who cannot vote. But yeah, I mean, that the other study is perhaps quite interesting as well, to see how the discussion is evolving on Twitter, and maybe that is like one advantageous aspect of this type of research as well, which is like often platform specific research, where I just want to know what's going on in the platform. I don't so much want to make a generalization beyond the platform. So yes, I can see that in those cases that we would like to see what the bots are saying, and especially if they are affecting change and actually having a causal effect on opinion dynamics over time. So yeah, I think that's maybe a wishy-washy way of answering your question.
Not at all. Very, very precise way of answering that question. It's just as you pointed out, like this causality part, then in turn is very hard to measure. Like how do they really influence the real world events? Yeah.
Yeah, I mean, just maybe a quick note about like causal inference. I think there's also some recent exciting work about using causal inference and text data. Again, I think the neat thing about this is that it's taking a lot of like inspiration from the theory in the traditional social sciences about causal models. So yeah, lots of potential there again.
And while both of you were talking about bots, and hopefully I can say what I would like to say, is I was thinking, for example, about humans who have a profile on Twitter, who say, for example, they are female or they are, and then I know that there are a lot of profiles by humans which are fake. There are no bots. And I was thinking about, okay, that's the next challenge, especially if we are looking on mining an opinion regarding also politics and things like that, Again, it's not a bot, it's a human being behind a fake, if we would like to call it like this, behind a fake profile. So do you have some experiences or insights also regarding this point? Because I can imagine that's really challenging to detect fake profiles.
Yeah, I mean, for sure. I had some past experience during my master's study about understanding fake engagement on Instagram, like fake likes and stuff. And I think our takeaway there was that, again, this kind of binary classification is maybe not realistic, because people have these kinds of shades of fakeness, let's say, that they have like some type of inorganic behavior, but maybe some type of real behavior as well. And I think like there is this kind of very rich literature about this inorganic behavior, because there could be things like sock puppets, where people create like fake profiles to kind of boost their own opinions. And that has some overlap with bots as well. But yeah, so there are these kinds of like really nuanced inorganic behavior that are there on these social media platforms like Twitter. I mean, the contrast is with like something like Facebook, which at one point of time had this policy that you could only be on social media with your real name. And I believe like some people are also now thinking, some influential people are also now thinking about doing that on Twitter, where there is some type of authentication required. But I mean, those things are also complicated because many people have very genuine reasons for using, say, fake names or pseudonyms, like trans people or domestic abuse survivors. And so if you kind of ask people to only have real names, which would make like some research more easy, it could also have some other effects and also make research tougher for certain harder to reach populations as well. So there are these trade-offs involved. Again, I'm sorry, there are no good answers. I wish I had more like concrete answers, but I just think like there are many of these issues and that we need to maybe think about and have like more context dependent solutions about.
Yes, so it's definitely great to talk with you about this topic, Indira, and especially because these are really complex questions we have on the table right now, and these are especially also questions which are still in the making and still in the making to be researched. And it's really great to hear your view and also your opinion and your information about it. And yes, so with this, I would again thank you very, very much for your talk today and for your presentation, because it was very informative. And we are really happy to have you here today. And with this, and also with the look on the clock, we are also in time with our first talk today. And this is maybe also the point for me to switch again to German language. Thank you again for your talk. Vielen lieben Dank, Indira. Und damit auch an das Publikum, an Sie herzlichen Dank für Ihre Aufmerksamkeit. Und wir freuen uns schon sehr darauf, dann zu unserer nächsten Sitzung eben auch weiterzumachen. Und dementsprechend sehen wir uns zu unserem nächsten Termin zur digitalen Ringvorlesung Informationswissenschaft und Digital Humanities.